everyone, welcome back to mahafarkar.co.in. In today's video, we are going to learn about simple pendulum. Before going through the simple pendulum, we have learned already about linear simple harmonic motion. It is the motion in which the restoring force is directly proportional to the displacement but in an opposite direction. And restoring force always acts towards which position? Mean position. So, this principle we are going to use to explain the simple pendulum, and we are going to prove that simple pendulum performs linear FHM. Simple pendulum performs what? Linear FHM. This one we are going to prove, and second we are going to find out period of simple pendulum. So let's start the article. Before, what is simple pendulum? Then it's very simple. See, such type of heavy object, like if you have used the ball which is used to study the vernier caliper in standard 11 with hook, that type of spherical ball, we call it bob, suspended from rigid support using thread. That thread should be very massless, very small mass, inextensible and twistless. It should not get twisted around its length. So such type of thread once we use and we suspend the heavy object, then it forms what? Simple pendulum. So I can say the heavy point mass suspended from rigid support using masslessness, inextensible, twistless string called as what? Simple pendulum. Okay, practically no string can be perfectly massless. Because of that, we cannot say there is a perfect massless string. So I will say masslessness. Its mass is very small. So now let m be the mass of object. That object is bob. If attached to the thread, let L be the length of the string. Okay. When bob is here, the tension acting on the string is always toward the point of suspension. So let T be the tension acting on the string. T be the what? Tension acting on the string. And finally, that bob is displaced by angle theta. So theta be the angle made by string. With vertical. Theta be what? Angle made by string with the vertical. Now what points we need to discuss here? This is very simple and important. Now see, when the object is at mean position, its total weight is in a downward direction and the tension acting on the string is in upward direction. They cancel each other so that the bob is in the equilibrium. But now when it is displaced by angle theta, then this will be the direction of actual weight, which is balanced by the tension in the string. So the weight will be resolved into two components. So if pendulum is displaced through small angle theta, then the weight of pendulum can be resolved into first part, that is say mg cos theta, which is going to balanced by tension in the string. So mg cos theta can be equal to tension T. See, this is equation number 1. Now second component is what? Mg sin theta. Mg sin theta will be which component? Horizontal component. So if you consider at any instant, if this is angle theta, this will also theta. Here also it is going to resolve into this side. So if this is angle theta, this will be mg cos theta and this will be what? mg sin theta. So either it is at extreme position A or extreme position B. The mg sin theta is always directed towards the mean position. So which is directed towards what? Mean position. Directed towards mean position. So we know that when particle is directed towards, when this component of force directed towards the mean position, so it is act as which force? It is act as what? Restoring force. Therefore F can be equal to mg sin theta. I will say it is negative. Why negative? Then very simple logic. Theta is opposite to the mean position and the component of force is towards the mean position, so theta is what? Negative. I said initially theta is very small. If theta is very small, so as theta is small, we know that if theta is small, then sin theta is approximately always equals to what? Theta. So substituting here, then what do I will get? F equal to minus mg into theta. Now, just imagine that pendulum has completed the circle. So this portion is nothing but what? The arc of the circle, and this length will be act as the radius of the circle. So here length is equals to, we know that according to the formula, length of arc, length is equals to r into theta. So what I will get? Theta equal to L upon r. Here instead of writing r, I have indicated it by x, since r equal to what? X. So substituting here, what I will get? Something is wrong. Theta equal to L upon x. So I will write F equal to minus mg into L upon x. Okay. Sorry, I had made one mistake here again. If theta is small, so length of arc is given by x is equals to L into theta. What is theta equal to? Theta equal to x upon L. Replacing here, I will get F equal to minus mg into x upon L. I can say minus mg upon L into x. These things are constant. Weight and length are constant. So theta equal F equal to minus k into x, where k can be what? Constant. It's not force constant here, but it can be any constant. So when F is directly proportional to minus x, there I will say F directly proportional to minus x. Hence, I can say simple pendulum performs linear SHM. Simple pendulum performs what? Linear simple harmonic motion. Okay. Now we need to find out the period of simple pendulum. So C, period of simple pendulum. We have one basic formula, period equal to what? 2 pi upon omega. So this is equation capital A. I will write it as T1. Now we have one equation. What is that equation? This one. We have F equal to mg x upon L in magnitude. What is force is equals to mass into acceleration equal to m into gx upon L. M get cancelled. Okay. Or this formula also can be written as 2 pi upon root of a upon x. How? Just check out. Okay. M get cancelled, so a equal to g into x upon L. So a upon x can be equal to g upon L. So if I substitute this value here, then period of simple pendulum can be equal to T1 equal to 2 pi divided by root of g upon L. L will be shifted to the numerator, then what I will get? 2 pi in root L upon g. This is the formula for period of simple pendulum. Okay. Now using this formula you can have few laws of simple pendulum, and these are very simple laws. from the formula only one can get the laws. As we know, 2 pi will be always constant. So first law I am writing period of simple pendulum according to the first law. It is called law of length, is directly proportional to, as you can see, square root of length. Directly proportional to what? Square root of length. Second law is what? Inversely proportional to square root of acceleration due to gravity. Okay. Now you can say that no mass is involved in the formula for period. So T, this will be the first law, this will be the third law. T is independent of mass of the bob. Okay. And again fourth law also can be stated there, that T doesn't depend upon the amplitude. Whatever is the amplitude, value of T doesn't change. So this was the article for us, simple pendulum. Simple pendulum performs linear simple harmonic motion, that we have proven here. The formula for period of simple pendulum, that is given here. Here I made mistake in the formula. Kindly ignore that mistake and go through the basic formula. Length of arc is equal to r into theta. In that I got confused actually. This should be the x for us. R should be the L and theta. Okay. So this will be the proof that simple pendulum performs linear simple harmonic motion. This gives the formula for period of simple harmonic motion. Here one term will be there. In short, if I tell, it is called seconds pendulum. The pendulum for whom period is equals to 2 seconds, then it is called as what? Seconds pendulum. The simple pendulum which takes 2 seconds to complete one oscillation, it is called as what? Seconds pendulum. For seconds pendulum, length is always equals to 1 meter or approximately equal to 100 centimeter for earth. Okay, this we are going to keep in mind. I hope you understood this article also. Thanks for watching mahasarkar.co.in. Have a nice day.